The universe is a vast, dark expanse, stretching far beyond what our eyes can see, filled with mysteries waiting to be uncovered. Occasionally, this darkness is pierced by the explosive deaths of massive stars, supernovae, brief, brilliant flashes that outshine entire galaxies for a moment in time. These cosmic detonations are more than just spectacular light shows. They are the universe's forges, creating the heavy elements essential for life and scattering them across galaxies, seeding the cosmos with the building blocks of planets and people. The iron in your blood, the oxygen you breathe, the calcium in your bones, all were created in the hearts of stars and spread by supernovae, connecting us to the cosmos in a profound way. Without these powerful explosions, the universe would lack rocky planets, complex chemistry, and the very conditions needed for life as we know it to emerge and thrive. Supernovae also serve as cosmic yardsticks, helping us measure the vastness of space and the passage of cosmic time. Type Ia supernovae, with their remarkably consistent brightness, let astronomers measure immense distances and map the universe's expansion with incredible precision. Observing these standard candles led to one of the most profound discoveries in modern science: dark energy, the mysterious force accelerating the universe's growth and shaping its ultimate fate. But supernovae are rare and fleeting, appearing without warning and vanishing quickly, making them difficult to catch in the act and challenging to study in detail. To find these cosmic events, we now rely on more than just human eyes. We turn to artificial intelligence, which can scan vast amounts of data and spot the subtle signs of a supernova in real time. This shift marks a new era in our quest to understand the universe, blending human curiosity with cutting-edge technology to unlock the secrets of the stars. Astronomy has transformed from a solitary pursuit to a data-driven science, with telescopes like the Zwicky Transient Facility generating more data than humans can process. Artificial intelligence, especially machine learning, now helps astronomers sift through this torrent, recognizing patterns and flagging anomalies. By training AI on thousands of images of cosmic events, we teach it to spot both the familiar and the truly novel. AI acts as a tireless observer, free from human bias, able to catch the faintest flicker of something new. This technology allows us to detect cosmic events as they unfold, not just after the fact. Imagine an AI that can warn us when a star is about to explode, giving astronomers time to mobilize global resources. In 2023, this dream became reality with the discovery of supernova SN 2023 ZKD, an event that changed the game. AI had become an indispensable partner in cosmic discovery. 730 million light-years away, in a remote corner of the cosmos, a massive star neared its end, locked in a deadly gravitational dance with a voracious black hole, its fate sealed by the invisible pull of its companion. Its erratic brightening, a faint, unusual signal, would have slipped through the cracks of traditional surveys, lost in the vast sea of cosmic data. But in July 2023, a specially trained AI at the Zwicky Transient Facility flagged this anomaly, recognizing a pattern no human had seen before. Unlike typical supernovae, this event didn't fit any known patterns or expected behaviors, puzzling even seasoned astronomers. The AI's alert prompted immediate human investigation, sparking excitement and curiosity throughout the observatory. For the first time ever, astronomers caught the prelude to a stellar explosion, witnessing the critical moments leading up to the cataclysm, not just the aftermath. The early warning allowed a global team of scientists to mobilize, coordinating telescopes around the world to observe the star's final moments in unprecedented detail. What they found was extraordinary: direct evidence of a massive star exploding while its black hole companion tried to consume it, a cosmic struggle never before seen in real time. The system had been brightening for years, a rare precursor activity, invisible to the naked eye, and only detectable thanks to the AI's relentless watchfulness. This wasn't just a new supernova, it was a new kind of stellar death, discovered from the very beginning, rewriting what we thought we knew about the life cycles of stars. With this discovery, AI had opened a window onto cosmic phenomena we never knew existed, forever changing the way we explore the universe. Thanks to an early alert from advanced AI systems, astronomers were able to witness a supernova event with an unexpected and dramatic twist. After the initial brilliant explosion, the dying star did something extraordinary. It re-brightened, surprising even seasoned scientists who had never seen such a phenomenon before. This rare encore was triggered when the powerful blast wave from the supernova slammed into a dense disk of gas and dust, material that the star had shed in its chaotic, turbulent final years. The collision created a spectacular burst of light, revealing secrets about the star's violent past. All the evidence pointed to a binary star system, a massive dying star paired with a compact companion, most likely a black hole. The black hole's immense gravity had been steadily stripping away the outer layers of its partner, setting the stage for this cosmic drama. The AI's timely detection led astronomers to what can only be described as a cosmic crime scene, where a black hole was caught in the act of interacting with its doomed neighbor, all unfolding in real time before our eyes. This remarkable discovery, published in 2025, points to the existence of a new class of stellar explosions, ones that are shaped and influenced by the complex dynamics of binary star systems. Events like these, with their unusual light curves and mysterious precursor activity, are nearly impossible to detect without the help of AI. Traditional methods would have missed them entirely. SN 2023 ZKD was the first supernova of its kind ever observed, but astronomers are confident it won't be the last. With new technology, more discoveries are just around the corner. The universe is vast and mysterious, holding countless strange and spectacular ways for stars to die, many of which we have yet to uncover or even imagine. With AI as our guide, we are now better equipped than ever to uncover these cosmic mysteries and witness the universe's most dramatic finales. The study of SN 2023 DKD was a global effort, sparked by an AI alert that mobilized observatories worldwide. Rapid response networks are essential. Supernovae reveal their secrets in the first hours and days. The Young Supernova Experiment coordinated telescopes from space and ground, including NASA's Swift Observatory and the Magellan telescopes. Robotic telescopes provided round-the-clock monitoring, building a complete light curve of the explosion. Each observatory contributed unique data, creating an unprecedented dataset. This collaborative model, networking telescopes and sharing data, represents the future of astronomy. AI identifies targets. Global teams provide the follow-up. Together, they turn the planet into a single, coordinated eye on the universe. AI's impact in astronomy goes beyond finding supernovae. It's enhancing our instruments themselves. In 2025, NASA's James Webb Space Telescope faced image blurring in a key instrument. The fix wasn't hardware, but an AI-driven software called Amigo, developed in Sydney. Amigo used neural networks to model and reverse the distortion, restoring the telescope's sharp vision. Thanks to this digital pair of glasses, Webb now delivers its clearest images yet, from exoplanets to distant black holes. AI isn't just analyzing data, it's improving how we collect it, pushing technology to new limits. Our windows on the universe are clearer than ever. The future of discovery depends on this synergy between AI and advanced instruments. The next leap in cosmic discovery is coming with NASA's Nancy Grace Roman Space Telescope. Roman's panoramic field of view will make it a supernova-finding powerhouse, capturing thousands of events where Hubble found only dozens. This flood of data will help cosmologists refine our understanding of dark energy and the universe's expansion. Roman's frequent wide surveys are the perfect match for real-time AI analysis, enabling the discovery of rare and unusual transients on an unprecedented scale. Combined with the Vera C. Rubin Observatory's vast ground-based surveys, AI will help us find these events weekly, not yearly. We'll move from isolated discoveries to a comprehensive understanding of how stars end their lives. The future of astronomy is a partnership. Powerful telescopes in space, intelligent algorithms on the ground. Together, they'll map the ever-changing universe. A new era of big data astronomy is about to begin. The AI-powered search for supernovae is reshaping astrophysics, from stellar evolution to the nature of the universe itself. Type Ia supernovae, our standard candles, let us chart cosmic expansion and probe dark energy with new precision. But the rare, oddball explosions like SN 2023 ZKD reveal the messy, dramatic lives of stars in binary systems. Studying these events teaches us about mass transfer, accretion disks, and the extreme physics near black holes. Each new discovery challenges our models and enriches our understanding of the cosmic ecosystem. This dual approach, measuring the universe's broad strokes and its intricate details, paints a fuller picture of our origins and fate. The iron in our veins and the accelerating cosmos are two sides of the same story. Thanks to AI, we're reading that story in unprecedented detail. We're entering a new era, where AI and next-generation telescopes fundamentally transform how we explore the universe. AI tirelessly scans the skies, flagging both expected and unknown phenomena, freeing astronomers to ask deeper questions. The story of SN 2023's KD is just the beginning, a proof that this partnership works. Understanding supernova is crucial for assessing the habitability of distant worlds and the galactic environment. AI techniques developed for astronomy will ripple into other space sciences, from spacecraft navigation to planetary exploration. We're no longer passive observers. We've built intelligent scouts to guide us through the cosmic ocean. The journey ahead is about seeking the unknown, not just confirming what we expect. The greatest discoveries will shatter our paradigms and reveal the universe in new light. With AI as our guide, we're ready for whatever surprises the cosmos holds.